All right, so this lesson is going to go over derivatives using data. One of your 6 FRQ questions is for sure going to be a data question. And some of the questions proposed here could be the exact same questions you're going to see on your AP exam on that question at the end of the year. So we're kind of starting today to start already talking about what do FRQs look like? How do we approach these problems? How do we answer them in a way that is so perfect that they have no choice but to give us all the points? All right, so in this problem, we have water flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function W for 0 to 24, where T is measured in hours, W of T is measured in gallons, also given to us in the table here. Values of WT at selected values of time T are shown in the table below. All right, so our first 2 problems aren't really calculus problems. They're more of a previous class, but this is going to get us practicing how to write out a solution on a free response question. All right, so use the data in the table to find W of 8. All right, so this is simply just picking a number out of the table. W of 8 is equal to 221. All right, then it says using appropriate units, explain the meaning of your answer. All right, so W of 8 is the amount of water in gallons in the tank at T equals 8. All right, so when you write out an explanation or meaning of your answer, you should have 3 things, and they form the acronym NUT, N-U-T. All right, so you're going to have a noun, you're going to have a unit, and you're going to have a time. Sometimes time is actually the noun, and then your time part of your answer refers to the input. So if you want to say your noun is the output and your time is the input. Most problems, time is the input and something else is the output, so that's why we go with the noun, unit, time, and also forms a nice acronym, NUT. But occasionally you'll see this on the very next problem, actually, where your input is actually something else other than time, and your output is actually the time. So it is possible to kind of get those switched. All right, so we identify those. W of 8 is the amount of water. Maybe I should have written in the tank first, but the amount of water is our noun. In gallons is our unit. At T equals 8 is our time. All right, part 2. Use the data on the table to find W inverse of 257. So W inverse of 257 equals, okay, there's 257. The inverse answer is 12. Okay, so using appropriate units, explain the meaning of your answer. W inverse of 257 is the time at which there are 257 gallons of water in the tank. All right, now I'll tell you, I forgot to put something. And this would lose me credit. I would not get credit for this answer right here. Okay, so I have my noun. Noun is W of 257 is the time. Okay, that's my noun. All right, and I have my time, which is my input. The 257 gallons of water, that is my time. All right, that was my input in this problem. All right, so what I forget? I forgot units. Okay, I have units down here, but that's attached to the input. I need my units on the output. Unit has to be part of the output. Okay, so is the time, and I needed to include in hours. All right, if I include in hours right there, then I get my unit. And now I have all 3 parts. Okay, you have to have all 3 of those parts or you're not going to get a point for the explanation being correct. All right, now we're going to do a calculus problem. All right, using the data in the table, find an approximation for W prime of 15. Okay, it is impossible to find a true derivative if you're only given a table of values. But what you can do is you can approximate a derivative by finding the slope. Okay, so W prime of 15. All right, now it says 2 things here. So we're going to need to have at least 2 parts. Show the computations that lead to your answer. What show the computations means is they want to see a difference quotient. If you do not show a difference quotient as part of your work, you will not receive credit for the show the computations part of the problem. Okay, so we need to make sure we show a difference quotient. So what you're going to do is you're going to pick 2 points from the table, and you want to pick the 2 points that are closest to 15. Okay, so 15 falls right in between 12 and 16. So we're going to pick these 2 points. And this is how we are going to find our approximation for the W prime of 15. So it's just the slope formula. It's algebra 1 style. 294 minus 257 over 16 minus 12. Okay, so you may be able to do those in your head and write down the answer right away, but don't. Remember, you have to show a difference quotient. So write it just like this. And then the benefit of writing it like this is you actually can stop. You do not need to simplify this answer. Okay, this is what we call a safe stop. Okay, I'm going to simplify it just because we're doing notes. And if this were a multiple choice question, it would be simplified. So the simplified version of this would be 37 over 4. And that doesn't reduce, so we leave it like that. And then I'm going to put my units on my answer this time. So this is in gallons on top per hour on bottom. So in gallons per hour. Okay, so as I mentioned, this right here, this gets both points. You get the computations points because you showed a difference quotient. You also get the answer points because it is the correct answer. Once your answer is dependent only on numbers, you can stop right there. Okay, we call this a safe stop. Okay, it's safe because you're not going to make a mistake by doing a wrong calculation. What if you've written 39 over 4 instead of 37? Well, now you've lost that point. So this answer point you had right here, if you write 39 over 4, gone. You still get the computations part because you showed a difference quotient, but you no longer get a point for the answer because you did too much. Okay, don't do too much. All right, now we still haven't explained the meaning of our answer, so let's make sure we complete our work here. So W prime of 15 is so this is a rate of change. You can tell by the units, you can tell because it's a derivative. W prime of 15 is the rate of change of the amount of water in the tank in gallons per hour at t equals 15. All right, so same rules apply. You need a noun. So our noun was long this time. W prime of 15 is the rate of change of the amount of water in the tank. All of that is our noun. What they're looking for mainly is the rate of change part in that. They want you to have identified this as a rate of change of the correct thing. So it's rate of change of the amount of water. All right, our units are in gallons per hour. So there's our U, and then we have our time, T equals 15. So there's our NUT acronym. All right, use data in the table to find the average rate of change of W of T over a time period from 4 to 20. Show the computations that lead to your answer. So they've reminded us what average rate of change looks like. So for us, our function, instead of F, we have W of 20 minus W of 4 over 20 minus 4. This right here will get you the computations point. So what we've just shown is earned that computations part, but we have not earned a point for the answer yet. Okay, on the last problem, I did not write it in function form like I did here. I just plucked those numbers straight out of the table, put it in there. So this not only earned us the computation point, it also earned us the answer point. Okay, but this down here, you must pluck the numbers out, and you can't leave it in function notation. You have to have the actual values in there. So once we grab those values from up here, 327 and 184, 327, I wrote that wrong, 327 minus 184 all over 20 minus 4. This right here, with our units attached, gallons per hour, is our safe stopping place. Okay, for our notes, we're going to continue and simplify because that's how a multiple choice would be. Let's see, 7 minus 4 is 3. 32 minus 18 is 16. 20 minus 4 is 16. And I think that's as far as we can go with that. Gallons per hour. All right, part E, for 0 to 24, must there be a time t when the tank contains 265 gallons of water? Justify your answer. All right, so anytime they ask you something like this, must there be a time t? All right, this is asking about existence. And what we will learn, we've only learned one of them so far, but we will have learned about a couple different existence theorems. Okay, so the only one that we've learned so far is the intermediate value theorem. And what the intermediate value theorem does is it determines if a value must exist. It doesn't tell us what the value is, but it tells us that there's one there. Okay, and that's all they're asking. Must there be a time t? Must it exist? So we're going to be using the intermediate value theorem. Remember, there are 3 things you need to write down to get full credit on an intermediate value theorem. Number 1, you must state that the function that you're dealing with is a continuous function. Okay, this is something on a data problem that they will have had to tell you in the problem. All right, they would have had to tell us that this is a continuous function, or they would have had to tell us something else so that we can figure out that that means it's continuous. And that's actually what happened here. So second sentence, the amount of water in the tank is modeled by a differentiable function W. All right, we learned in our other lesson that when a function is differentiable, that means it has to have been continuous. Because if a function is not continuous, that means it is not differentiable as well. Okay, so we have to state that we know our function is continuous, and we have to state why we know that. Okay, so we're going to start with just restating what they told us up there. W of t is differentiable. And is therefore continuous. All right, so that's going to be a point right there that you are identifying continuity and you're attaching it to the reason that you know it's continuous. If all you do is say W of t is continuous, you're probably not earning that point there. You have to say it's differentiable and is therefore continuous. All right, second part is we need to do our inequality. We're trying to determine existence of 265. So we need to place 265 in between 2 numbers in the table. So you can pick any 2 numbers that you want that 265 falls in between. I can use these same 2 right here because 265 is between those 2. I usually try to use the first and the last if I can. And I certainly can do that here as well. But any combination of 2 numbers where 265 is between them and they're given in the table will work just fine. All right, I am going to use the first and the last one. So W of 0, which equals 150, is less than or equal to 265, which is less than or equal to, 357? Yeah, 357, which equals W of 24. All right, and then what you've stated is continuous. You've shown that the y values between 2 other y values, then you can state your conclusion. Therefore, IVT applies. So we've invoked the name of the theorem, we've stated the 2 conditions that have to be true, and so we've done everything we need to do to get full credit on this problem. All right, so flip it over in the back. These last 2 you are going to need a calculator for, so if you need to pause the video, grab your calculator. You can also do this on Desmos if you'd like. I think I'll probably show you both ways. All right, so they love to do this on these data problems. They give you a table, they ask you a few questions about the table, and then all of a sudden in part C, they introduce a function. And this function is actually modeling the same thing that the table does, a model for the amount of water in the tank. Okay, they've named it something else. It's called A now because we can't call it W because W is already defined by that table. And A is defined by this equation right here. But they measure the same exact thing. Okay, so A of t is measured in gallons, t is measured in hours. Now it's asking us to find A prime of 15. Okay, we could do this one by hand, but it would be, we'd be dealing with some big numbers. We have this weird fraction in front, so we're going to practice finding the derivative in the calculator. This is actually the second thing you need to be able to do in the calculator on the AP exam. First one that we've practiced is graphing a function in an appropriate window. Second thing is being able to find the derivative at a point, which is what this problem is asking us to do. So since we're doing this as a calculator problem, I'm going to write calc over to the side here. You don't have to write very much. For instance, you don't have to find the derivative by hand. Please don't do that. If you're on a calculator problem, don't do anything by hand that the calculator can do for you. Okay, that goes back to your safe stopping place. If you make a mistake with your derivative by hand, even if you write the right answer at the end, it's possible that they could take that point away because your derivative is wrong. Okay, you don't want to write anything that's wrong on your answer. That introduces the opportunity for you to not earn some credit that you should have. Okay, so we're not even going to bother finding the derivative by hand because we're going to let the calculator do all the hard work for us. The only thing you need to write here is a prime of 15 is equal to. And then the calculator is going to find this for us. Okay, so we're going to plug this in. I'm going to do this a little differently in the calculator this time. I usually have us graph the function and then do the derivative on the graph. But I'm going to have us store this function, I think. And I think that'll be a little more clear, or at least I'm hoping so. All right, so we're going to go to a calculator page. And we're just going to start by typing a of t, like that. And then if you hit the control and then this button that's next to 9, you'll see a little colon equals above that, like that. That's the one you want. All right, then we're just going to type in the function. So 1 over 225, parentheses. All right, it's negative t cubed plus 30t squared plus 1800t plus 33,750. Got an extra 8 in there. There we go. All right, hit enter, says done. So we've now stored this function in a of t. So now I want to find the derivative at a point. So there's a way to type this out, but the easiest way to do this is go to menu. There's a calculus menu, so pick that, number 4. Okay, if you're using a CX instead of a CAS, you're not going to have that top one. So my number 2 will be your number 1, and your number 1 will also say numerical derivative at a point. Same thing. Okay, so we want the derivative at a point, which is that variable. My variable is t in this one, so I'm going to type t. The value we want is 15. We want the first derivative, so hit OK. And then all you have to do is fill in your function. Well, we've named our function up here, a of t. So you just type that in, hit enter. There's your answer, 9. Okay, so back on your notes, you just write 9. Make sure to include your units. We know a derivative is a slope. Slope's going to be in gallons per hour. It did not ask us to interpret this or to explain the meaning of this in the context of the problem. If we were asked to do that, it would be the exact same answer as w prime of 15 was on the previous problem. So that's why we're not asked to do it twice here. All right, that is all you have to write on a calculator problem. Okay, so do not write more than you have to. All right, so use the model given in part F. So this is the model, the equation, to find the average rate of change of A over the time period from 4 to 20. Okay, so I'm going to have us write out the difference quotient. Okay, even though they didn't say show the computations that lead to your answer, I do think you should do that as much as you can. Okay, so this is going to be A of 20 minus A of 4 divided by 20 minus 4. All right, and that's all I'm going to write, and we're going to use the calculator once again to calculate that whole thing for us. Okay, so I'm going to hit Control divided by, and then I'm using my A, so A of 20. You can see how the A is bold when I type it. That means the calculator recognizes it. It's a function that we've typed in. A of 4. Like, let's say I typed in B. See how B doesn't turn bold? That's because we don't have a function saved as B. We have a function saved as A. Over 20 minus 4. All right, I'm going to put a decimal after mine. I want it in decimal form. The CAS calculators don't automatically go to decimal form. The CX calculators do. So you don't have to put that decimal there if you have a CX calculator. So there it is, 8.995 or 8.996. The AP exam accepts either version of the answer. So 2 possible answers here. Truncating is when you just cut all the decimals off after the one you want. So we want 3 decimal places. You cut everything else off. That's where the 995 comes from. Or rounding, which is going to take that 4th decimal place, and if it's a 5 or higher, it's going to round up to a 6. I prefer rounding because that's how I've always done it. 8.996. Make sure to include your units, gallons per hour. All right, or 8.995 would be okay as well with your units attached. All right, that's derivatives of data. You're going to have a data question as your free response. These are some derivative questions they can ask about that. We'll definitely revisit data questions many times this year as we learn more and more stuff, and there are more and more different types of questions they can ask in a data problem as well. All right, hope you enjoyed that, and I will see you for the next video.